The question sounds simple and almost childish at first, like something you ask while staring at the night sky and waiting for a shooting star to answer back, "Where is everybody?" Not do aliens exist in the abstract, not could there be microbes under the ice of some distant moon, but the sharper, more unsettling version. If the universe is so big and so old, and if life is even moderately common, then why don't we see any signs of anyone else? No signals we can clearly recognize, no giant structures blotting out starlight, no obvious engineering footprints across the Milky Way, no unmistakable traffic in the radio sky, no probes drifting through our solar system with a return address. The silence is the point. The gap between what feels likely and what we observe is the Fermi Paradox, named after the physicist Enrico Fermi, who reportedly cut through the optimism of there must be aliens and with a blunt follow-up that still echoes. So where are they? To understand why this is a paradox at all, you start with scale. The observable universe is staggeringly large, and even if you restrict your attention to our own galaxy to avoid the complications of cosmic expansion and the impracticality of intergalactic travel, the Milky Way alone is an ocean of stars. It contains hundreds of billions of them, and we now know planets are not rare prizes, they're normal. Many stars have them, and many have multiple. Among those planets, there should be enormous numbers that sit in the broad category of could be habitable, meaning not necessarily Earth-like paradise, but worlds with conditions that might allow liquid water and chemistry complex enough to build something living. Now add time. Our galaxy is ancient. It has existed for billions of years longer than complex life has existed on Earth. And even if the earliest era was too violent for stable biospheres, there has still been an immense stretch of calm enough history for life to arise, diversify, and on at least one world, develop intelligence and technology. On Earth, life began relatively early, once conditions allowed it. Intelligence capable of building radios and rockets took much longer, but once it arrived, it accelerated quickly. From a cosmic perspective, the jump from can shape rocks to can shape energy happens fast. That leads to the uncomfortable math. Even if the odds of life are low, even if the odds of intelligence are lower, and even if the odds of technology are lower still, the number of tries is so huge that someone else should have made it feels hard to avoid. And if someone else did, and if they had even a modest head start, you'd expect consequences. Not necessarily alien empires with flags, but artifacts, signals, probes, waste heat, megastructures, altered star systems, anything that screams, this wasn't made by geology. The paradox isn't that we haven't met aliens face to face. The paradox is that, so far, the universe looks quiet in ways that are hard to reconcile with the naive expectation of crowded skies. Before jumping to terrifying conclusions, it helps to place strict limits on what we could realistically detect. Most of the universe is beyond practical reach, not because it's merely far, but because distance and time are linked by physics in a way that punishes ambition. Signals weaken, travel takes generations, and even at the speed of light, crossing the Milky Way is a project of deep time. This matters because when people imagine alien civilizations, they often imagine instant reach, like the galaxy is a neighborhood, and everyone can pop over for a visit. In reality, even a civilization with extraordinary engineering would be constrained by speed limits, energy costs, and the sheer difficulty of keeping complex machines and living beings functional across vast distances. But that's not enough to dismiss the paradox, because you don't need faster than light travel to change a galaxy. You only need persistence and replication. If you can build spacecraft that travel between stars slowly but reliably, and if each successful colony eventually launches its own ships, then expansion becomes exponential. It's not about a single ship crossing the whole galaxy, it's about a spreading network. Even with conservative travel speeds, the timescale to seed much of the galaxy could be far shorter than the age of the galaxy itself. That's one reason the silence feels heavy. With so much time available, why hasn't anything like that happened, at least once, in a way that leaves visible fingerprints? One framework people use to think about this is the idea of types of civilizations. Not as a real classification we've observed, but as a way to imagine energy scale. A planetary civilization would use the majority of the energy available on its world. A stellar civilization would harvest a significant fraction of its star's output, potentially with enormous collectors or swarms of structures orbiting the star. A galactic civilization would, in principle, tap into energy at the scale of a whole galaxy. The more energy you use, the harder you are to hide, because energy used tends to produce waste heat. Even if your technology is efficient, thermodynamics demands that large-scale computation and industry leave a thermal signature. So if there are stellar-scale civilizations in our galaxy, why don't we see stars with unnatural dimming patterns, weird infrared excesses, or unmistakable engineered light curves? We do see strange astronomical objects, but none have yet crossed the threshold into "this must be a megastructure," and the simplest explanations keep winning. That doesn't mean megastructures don't exist. It means the burden of proof is high, and so far, nature has proven more creative than our initial assumptions. Another crucial piece is the difference between existence and detectability. A civilization can exist and still be nearly invisible to us if its communication methods don't intersect with ours, if it deliberately avoids broadcasting, or if its technological phase that leaks signals is brief. Humans have been radio loud for a blink of time. Early radio and television broadcasts spilled into space in a bubble expanding at the speed of light, but that bubble becomes faint quickly. More modern communication trends toward cables, fiber, tight beams, and low-power signals that don't spray into the sky. In other words, technological progress might make civilizations quieter, not louder. If the loud phase is short, then even if civilizations are common, the odds of two loud phases overlapping in time might be small. That alone could explain some silence without invoking catastrophe. But again, the paradox persists because signals aren't the only expected sign. Long-lived artifacts might remain even when civilizations go quiet, unless something reliably prevents long-lived expansion or long-lived engineering. This is where the idea of filters comes in, often called the Great Filter. Think of the path from dead matter to galaxy-spanning civilization as a chain of steps. Planets form, stable environments exist, chemistry produces self-replication, simple life arises, complex life evolves, intelligence emerges, technology emerges, and then technology survives long enough to expand. If any one step is extremely unlikely, then most worlds will fail there. A filter is a step that almost nobody passes. The terrifying question is not just whether there is a filter, but where it sits relative to us. If the hardest steps are behind us, then we may be rare and early, a precious fluke that already survived the worst bottlenecks. That is a comforting kind of loneliness. The universe is quiet because life is difficult. Intelligence is rarer, and technological civilizations are extraordinary. In that scenario, the silence is a compliment, a sign that we are special in a statistical sense, and it places a moral weight on us. If we let ourselves go extinct, there may be little else out there to carry the torch. But if the filter is ahead of us, then the silence is a warning. It would imply that many civilizations make it to roughly our level and then reliably fail before they can spread or become visibly detectable. That's the version that keeps people awake, because it turns the galaxy into a graveyard not of bones, but of ambitions that ended at the same cliff edge. What could a future filter look like? It doesn't need to be a single dramatic doomsday device. It could be an accumulation of pressures, ecological collapse, resource exhaustion, self-inflicted warfare, runaway technologies that outpace wisdom, or simply the fact that complex systems are fragile and tend to break. The great in Great Filter doesn't necessarily mean one event. It can mean a consistent statistical trap. Consider how quickly humans gain the power to reshape the planet compared to how slowly our institutions adapt. We have global reach, but not global coordination. We have immense energy tools, but uneven incentives. We have the ability to create novel biological agents, novel autonomous systems, and novel weapons. A civilization might climb the ladder of power faster than it can evolve the restraint to use that power safely. In that case, the filter could be built into the nature of intelligence itself. The same traits that enable tool use, curiosity, competitiveness, expansion, could also generate existential risk. If this pattern is typical, then many civilizations may flare into existence briefly and then vanish, leaving only quiet worlds and maybe faint, decaying artifacts. The universe would be full of almosts. Another category of explanations is that the paradox is an illusion created by our expectations. We assume that intelligent life will expand outward, build visible structures, and announce itself, because that's how humans behave when resources and ambition align. But aliens might not behave like us. They might develop values and goals that don't include expansion. They might find inward directions more compelling than outward ones. Imagine a civilization that reaches a level of technology where it can build extremely powerful computation and simulation. At that point, a large fraction of its meaningful experience could occur inside artificial environments. If you can create worlds of any design, populate them with art, challenge, joy, novelty, and social complexity, then the incentive to physically colonize distant, cold planets might diminish. Why spend centuries crossing interstellar space and wrestling with hostile environments when you can build endless richness at home? This doesn't require mystical thinking. It's a simple trade. Physical expansion is slow and expensive, while information expansion could be fast and cheap. A civilization that chooses to compress into dense, efficient habitats near a stable energy source might be extremely hard to detect, especially if it optimizes waste heat management and keeps its external footprint minimal. This is sometimes framed as the city-state model versus the empire model. Perhaps mature civilizations tend to become compact rather than expansive. If so, the galaxy could contain pockets of intelligence that rarely leave their systems, and we would have little chance of noticing, unless we look directly at the right star with the right instruments and know what signature to seek. But even compact civilizations should leave some detectable clue if they harvest stellar energy on large scales. Unless they don't harvest much, or they harvest it in ways that mimic natural phenomena, or they exist primarily around dim stars, or they operate at temperatures and wavelengths we haven't surveyed thoroughly enough. Then there's the possibility that we are looking in the wrong way altogether. Our idea of communication is heavily shaped by our own technological path. We listen for radio signals because radio is easy for us. But radio might be a primitive phase. A more advanced civilization might communicate through tight beams, neutrinos, gravitational waves, or methods that appear like noise to us. They might have no reason to use omnidirectional broadcasts that leak into space. They might use encryption, compression, or protocols indistinguishable from random static without the key. They might communicate in bursts or in narrow bands, or in ways that require being in the same local network. In that sense, humanity could be like someone shouting in a desert while everyone else is using fiber optics underground. The silence would be real from our perspective, but not from theirs. Even if signals exist, time can erase them. Civilizations could rise and fall on timescales that make overlap rare. Our species has had modern technological capability for a tiny fraction of Earth's history. If other civilizations exist, their peak activity might have happened millions of years ago. That sounds like a long time, but in the context of a galaxy, it's not unimaginable. A civilization could have built structures that later decayed, or it could have altered its star system in subtle ways that we haven't recognized. Ruins don't always scream their origin from afar. Space is harsh, but it's also a preservative in some contexts. Still, detecting an ancient artifact across light years is a technical challenge. There might be relics out there that we would miss because we don't know what relics look like when scaled to star systems. Another family of explanations is darker. Maybe life is common, but intelligent life is rare because complex multicellular life is hard. On Earth, simple life appeared early, but complex life took billions of years, and it required a long chain of evolutionary innovations and environmental changes. Eukaryotic cells, sexual reproduction, multicellularity, nervous systems, intelligence. These might be improbably hard steps. If any one of these is exceedingly rare, then most living worlds could be microbial forever. From that angle, the universe could be full of life and still empty of civilizations. That would satisfy the numbers without giving us neighbors. It would also be consistent with the idea that intelligence is not an inevitable endpoint, but a quirky adaptation that happened here due to specific pressures and accidents. But even if intelligence is rare, it only has to happen once nearby to break the silence. The fact that we haven't yet seen evidence might still suggest that something else constrains the emergence or persistence of technological species. Consider geography within the galaxy. Not every region is equally friendly. Some areas have higher radiation, more supernovae, more stellar crowding, more gravitational disturbances. Early in the galaxy's history, heavy elements needed for rocky planets and complex chemistry were less abundant. That means there might be a habitable window in both space and time, a galactic zone where conditions are stable enough for complex life, and an era when metals are abundant but catastrophic events are not too frequent. If that window is narrow, then the number of civilizations at any one time could be lower than naive estimates. It could also mean we are early. Complex life might only have become broadly possible relatively recently on cosmic timescales. If so, the silence could simply reflect that the party has barely started. That idea feels comforting because it replaces doom with timing, but it is hard to prove. And it still leaves open the question of why we don't see at least a few older civilizations that got started earlier within that window. Another explanation is deliberate concealment. If the universe contains older civilizations, they might have reasons to avoid being detected by younger ones. This could be benevolent, like a policy of non-interference. Don't disrupt developing civilizations. Let them grow naturally. Observe quietly. Or it could be cautious, like ecological quarantine. Avoid cross-contamination of cultures and biospheres. Or it could be defensive. Broadcasting your location might attract predators. In that scenario, silence is rational behavior. Our dark forest universe is one where every civilization hides, because any signal could be a death sentence. This idea is emotionally compelling because it fits human fears about competition and hostility. But it's also speculative. It assumes that interstellar predation is feasible and worth the cost. Still, even if direct invasion is hard, automated systems change the calculus. A civilization could deploy self-replicating probes, machines that travel to other star systems, use local resources to build copies of themselves and spread outward. Such probes could be used for exploration, communication, or, in a darker scenario, sterilization. The scary part about self-replication is that it doesn't require a vast empire to sustain it once it begins. It becomes a process. A handful of initial seeds could eventually fill a galaxy with descendants. If hostile probes exist, they could prevent new civilizations from ever becoming visible by pruning them early. That would explain the silence in a brutal way. Everyone who starts to shine gets snuffed out before we can notice. It would also imply that our own future might depend on whether we can remain inconspicuous long enough to become resilient. But again, this is a story we tell ourselves in the absence of data. The fact that something is imaginable does not make it likely. We also have to confront a simpler possibility. Maybe we are alone in our neighborhood, at least for now. Not alone in the entire universe as an absolute claim, because the universe is too vast and our evidence too limited, but alone in the practical sense that no other technological civilization is close enough, loud enough, and overlapping in time enough for us to detect. That kind of loneliness is plausible, even if the universe contains life elsewhere. It would mean the night sky is not a bustling city, but a scattered archipelago with islands too far apart to see each other's fires. If that's true, then the Fermi Paradox is not a paradox, so much as a lesson about distance, rarity, and the danger of assuming that large numbers automatically produce nearby neighbors. Yet the emotional impact remains, because whether the silence is due to rarity, timing, concealment, or catastrophe, it puts us in a strange position. We are a species that can look outward and ask a cosmic question, and the cosmos does not answer back in any clear language. That silence can be interpreted as a threat, a challenge, or a responsibility. It forces us to think about what it means to be early, what it means to be fragile, and what it means to be the only voice we know in a vast dark. There is also a subtle trap in how we frame the paradox. We assume aliens means something like us, individuals, societies, machines, ships, messages. But the universe could contain forms of intelligence that don't fit our categories. It could contain slow distributed life at planetary scales, or intelligence embedded in environments or entities that exist primarily as patterns in plasma or as long-lived computational structures, near stars, or life that rarely manipulates matter in ways that look like industry. Even on Earth, intelligence expresses itself in diverse ways. Human technological civilization is one branch among many. If you extrapolate beyond Earth, the space of possibilities explodes. It may be that intelligence does not necessarily lead to radio, rockets, and expansion. It may lead to something we wouldn't recognize as civilization from light years away. We may be scanning the galaxy for neon signs while the real signatures are subtle shifts in chemistry, energy flows, or gravitational patterns that we are only beginning to measure. In that sense, the paradox may shrink as our instruments improve and as our imagination becomes less anthropocentric. But improved instruments could also make the paradox sharper. If we survey more stars, more wavelengths, more time, and still see nothing, then the silence becomes harder to dismiss. The most honest stance is that we don't know which explanation dominates. The Fermi Paradox is not a solved problem. It's a structured discomfort. It takes what seems like a straightforward inference, many stars, many planets, therefore many civilizations, and collides it with a stubborn observation. No clear evidence, no confirmed contact, no unambiguous artifacts. From that collision, a whole landscape of possibilities emerges. Some are hopeful. Life is rare, but we made it. The galaxy is young for intelligence. Advanced beings are quiet and harmless. We simply haven't listened properly. Some are neutral. Civilizations come and go and rarely overlap. Intelligence turns inward. Distance keeps everyone separate. Some are grim. Most civilizations self-destruct. Something prevents expansion. Predation or automated pruning keeps the galaxy sterile. Each possibility carries implications for how we should think about our future. If the filter is behind us, then our existence is precious and our duty is to survive and spread life. If the filter is ahead, then we should treat existential risk as the central problem of civilization, not a side topic. If the silence is due to timing, we might be among the first, and our actions could shape the long story of life in this galaxy. If the silence is due to concealment, we should consider the risks of broadcasting and the value of caution. If the silence is due to miscommunication, we should broaden our search strategies and learn what signatures advanced technology might produce. And if the silence is simply because we are alone nearby, then the only company we have is each other. And the only meaning we can extract from the cosmos is the meaning we decide to create. In the end, the Fermi Paradox is less about aliens and more about mirrors. It reflects our assumptions about progress, our fears about collapse, our curiosity about the unknown, and our longing not to be the only thinking thing staring into the dark. The universe may be teeming with life, or it may be mostly empty. It may be full of civilizations that never speak, or full of civilizations that died before they could. We can't yet distinguish between these stories with confidence. But the question, where are they, remains valuable, precisely because it forces humility. It reminds us that our current knowledge is a thin layer on an abyss of ignorance that a few decades of radio astronomy are not a final verdict on cosmic life, and that the absence of evidence is not evidence of absence, except in the limited practical sense that right now, with the tools we have and the sky we've surveyed, nobody is obviously answering. That means we live at a moment when the galaxy could be full of silent watchers, or full of ruins, or full of sleeping microbes, or full of nothing at all, and we have to build our civilization without knowing which is true. If that feels unsettling, it should. The correct emotional response to a vast, quiet universe is not certainty. It's caution mixed with wonder. It's the recognition that we might be early, we might be rare, and we might be fragile. And it's the realization that if we want the universe to contain voices, we may have to ensure ours does not go out.